Hello, my name is Eugenio Baggiacchi, and today I'm going to present to you the AI-Toolbox framework. This is our reinforcement learning library that I started around 6 years ago while I was doing my master in artificial intelligence. Our practical assignments at the time focused on writing algorithms to study how agents could maximize their reward in simple toy problems. Unfortunately, there weren't many open implementation available, and so we had to code everything from scratch, which limited our options as there was only so much time that we had available. So I started collecting my own implementations, and as the collection grew larger, I started documenting it and organizing it better so that other people could use it as well.
Today, my old collection has become a library called AI-Toolbox. It is stable and fully documented and is available online on GitHub, released under the GNU public license. It contains independent implementation of over 40 learning and planning algorithms for bandits, MDPs, POMDPs, and multi-agent bandits and MDPs. This library documents each class individually. For example, we can see that for Q-learning, we have a list of all public methods available, a brief description of the algorithm itself and what it does, followed by a thorough description of each function individually. The same is true for all other algorithms and utility functions in the library, for example Monte Carlo tree search or policy iteration, and so on and so forth. The documentation also contains tutorials that give a brief introduction to the concept used in the library, such as Markov decision processes, agents, and rewards. It also explains how this concept can be transposed in code, and how to customize the library to model problems in general. Currently we have a tutorial on MDPs, on reinforcement learning, and on POMDPs. Additionally, we explain how to extend the library and how code is organized to make it easier to discover the available functionality. The library is written in C++ and is fairly easy to use, and we can demonstrate this with a brief example. First, we instantiate one of the pre-made environments from the library. This creates a simple MDP grid world environment, where the agent needs to discover a path to a specific goal state. Next, we need to specify the algorithm that we want to use. In this case, we will use value iteration. Value iteration will perform planning, and the arguments here specify the horizon and the error threshold for convergence. Next, we apply our algorithm to our problem, and we obtain the resulting value functions. Now that we have a value function, we want to create a policy that acts according to it. Let's create an epsilon greedy policy to show how this can be done. In AI-Toolbox, policies are composable. Here we have first created a greedy policy that acts based on the value function, and then created an epsilon wrapper that performs a random action a certain percentage of the time. Finally, we can instantiate a simple experiment starting from state 0. First, we sample an action from our epsilon greedy policy. Then we sample a new state and reward from our original problem. And then we set our new state as our current state. And we are done. Although AI-Toolbox is written in C++, it provides Python 2 and 3 support via wrappers, which expose most of its functionality directly to Python. Here we can see how our example can be written in Python. As you can see, the code looks nearly identical line by line to its C++ equivalent. The initialization, the solver algorithm, how the problem is solved, creating the policies, and finally the experiment itself. Having a simple interface makes it easier for students to experiment and try out new things. At the same time as the library is written in C++, it can be much easier to extend it in the same language. This is why we focus so much on clarity and documentation, as we know that C++ can be a daunting language for many people. AI-Toolbox tries very hard to keep a uniform interface throughout the library. This allows to try different algorithms very easily and with minimal modifications to the code. We can show an example of this by replacing value iteration with Q-learning in our simple example. First, we include the appropriate file for Q-learning. We then replace value iteration with Q-learning. We can now skip the planning step, since Q-learning does not need it. The value function from the greedy policy will now come directly from the learner object. Finally, we add the Q-learning update step inside our experiment loop. And we are done. If, using the library, you encounter any issue or question, you can write on the GitHub issues page of the project, where we can help you figure out any problems. Before we conclude, I want to mention that while AI-Toolbox has a focus on accessibility and documentation, it is also actively used in research. It has been recently published on the Journal of Machine Learning Research, and we release new features fairly regularly. I hope you enjoyed the brief tour of the library and are welcome to try it for yourself. Thank you.